What's up, guys? Today we're going to do the rest of our 2048 game. I started last time, which is listing the functions like a table of contents. And then we filled in the little ones with the easy stuff, like checking to see if there's a 2048. If so, you win. And then we filled in some of the medium ones, like I think this guy was one of them, where you, at each turn, you get a random spot filled up. 90% of the time it's a 2, 10% of the time it's a 4, and you do that twice at the beginning of the game, but you have to say, well, there are only 2s, there's no 4s at the beginning, and blah, blah, blah. So that stuff is like slightly complicated, but the hard part was saved. We had like procrastinated it, partially because you just want to like get on a roll and do the easy stuff first and get it all in your mind, but also because once you get there, you'll know more facts because you'll have decided what you're going to do along the way. So I had left off where I thought, okay, making it shift left and right and up and down is going to be hard. So let's make it to where it's only one way, and then we just rotate the board. So like if you want to go up, well, we just rotate it and then move left and then move back. And then it will result in those guys having moved up effectively. And this happens before it's shown. The reader or the player doesn't see that, but in the math behind the scenes, it's doing it that way. And I thought that would be nice. And that's one thing I got from this tutorial here. I'm not going to open up the tab because it messes up the webcam on this Loom extension. But I'm not doing any of the code the same way they do. I just took that idea of like, oh, conceptually, it's nice to narrow it down to one direction. And even more than that, we can narrow it down to one line, because let's say we need to shift everything to the left. Well, we can just do one row to the left and then do that same thing on the other 3 guys. So we can really limit it to just one line, just do the hard stuff on one line, which is moving them over, combining the ones that are matching, making it so that they are all on the left and the blank ones are all on the right. And so I started to do that. And let me show you this folder. I put a link to this folder. See how it reloads the webcam, or at least on my view it does when I change the tab. I made one that I called harder because I had already done easy, medium, and hard. And the way that works is I wanted to really cut it down and try to make some elegant, simple version. So we're going to rotate our guy with these that are not quite as elegant as I hoped, but we'll figure it out. And then I made this. And when I did this, I thought I was a genius. I thought I had it very nicely. What it is you're going through your line, and if your guy equals 0, if a spot equals 0, we're going to swap it. So we're kind of pushing the zeros in one way and pushing the other stuff this way. And you can do that with, theoretically, these are tuples, I guess, with commas. You say A comma B equals B comma A, and it switches them. And I'm doing that with the I and I plus 1. So it's moving them, capturing the next guy and switching them if we need. Which, by the way, I've been talking about limiting this. We've got it down to one direction and then just one line. And now it's not even all 4. It's really only 3. We only have to look at the first 3 because as part of this process, we're going to grab the one next to it. So we never have to look at the 4th. So isn't this nice? We're only looking at 3 spots instead of 16. And then if our guy equals the one next to it, they're going to combine. So instead of switching, they're going to be double 1 and then 0. And I really thought I had it. And if you run this, it appears like it almost works. So like if I hit A, then they're going to move to the left. And if I hit W, they're going to go up. And this seems great, right? But here's one where if I hit up right now, what should happen in 2048 rules is that these 2 will combine and it'll be an 8 right under the 8. And then in a separate turn, we could combine those. But this, it just keeps going, and it's going to merge them all into a 16. So that's not good. In 2048, you don't have two things merge and then that one merge in the same turn. You have to separate it. And so I put some comments here. But I really like this. This very elegant chunk is what I want to start with. And it's not what I saw in this tutorial. They had a separate thing for shifting and a separate thing for merging, and really looking at it in a different way. But I do kind of like this. And then another thing you'll notice that's a problem is the alignment gets out of whack if you have two digits. So this top line has a 16, and now everything is bumped over. And it's really hard to read if you're trying to move up. You don't know if they're going to, it's no good. So I needed to find a way to fix this, and I needed to find a way to space everything evenly. Later, maybe next quarter or the one after, we're going to start doing stuff with a little bit of graphical circles and squares on the screen, moving them around using a thing called Pygame. And then we can take all this code and keep all the math behind the scenes, but just present it in a prettier way. Until then, we're going to look at the text. So what I've got here is the next version where I fixed those two things. And I called that hardest because I'm going in order, but I think I need one more after it, so who knows what that'll be called. The issues I dealt with in that were the printing and the logic of the shift and merge stuff. So let's look at the printing first. I used a thing called format, which is not cutting edge. There's actually a newer way in one of the newer versions of Python. But what you do with format is you say, I'm going to make a string with certain like magic characters that sort of give a description of what it is. Like this is right align or left align, or if you do a caret pointing up, it's a center and that kind of thing. And then so it's like creating a little format, and then you put your answer in there. And those are spaced in a way that looks all right. I think I want to add a blank row under it, because it looks weird if you stretch what's supposed to be a square in one dimension and not another. So maybe we'll do something like that. And that looks reasonable. They might be a little too far apart, and I'm not going to go all the way, but this looks okay when you have a 2-digit or a 3-digit. And I haven't played until I got a 4, but there's enough room. Okay. So that's not the golden, most beautiful, most up-to-date version. The new Python way is something called f-strings, which looks really good if you're printing a line where you can say like, oh, your name is name variable, and then mix strings and variables in one flowing line instead of having to do like pluses or something. However, I don't know how to do these guys, these little center and align symbols with it, so we'll figure that out. But this works, it's reasonable. And then the real hard part was this guy, which is when you shift and merge. I had it in that beautiful 4-line block, but that wasn't doing it right because that was moving all the way and then merging all the way and continuing to move and just piling everything up at the end. So if it had 8422, it would just go 16000, and that's not what we want. So what I realized is that you have to do the merge a limited number of times. Okay, you have to combine 4 and 4 to 8 or 2 and 2 to 4 a limited number of times. So I just go down the line. Do I combine these two? Do I combine these two? And do I combine these two? And that is, yep. And after each one, if you did merge, then you have to shift again. Because like if I combine these two 4s, I would get a blank here, which would be filled with a 0. But if there were stuff over here, I'd have to bump it over again. And then before you do any of that, you have to move everything to the left and move all the zeros to the right. So I ended up writing this, which is ugly. I hate it. I wish there's a way to make it more concise, and maybe like this little chunk, since it also happens here, I could make that a function, give it a name, which would actually be the same amount of lines. I'd be losing 3, and then spending 6 to get back to where I was, so I wouldn't actually shorten it. But it might be slightly more readable. I don't know. The way I tried to make this readable is to use S when I'm shifting and M when I'm merging as like our little iterative variable. I don't know if that's any good, but we'll see. It does, however, work, and this version absolutely plays the game. I put a couple comments to describe what things are doing, and the only part that's really, I think, wrong is right here, to check to see if you lose. There are some times in 2048 when you have no blanks, but you're still alive, like if there were some combinations that could be made. And in this tab over here, this tutorial, they have a whole function. I'm not looking at it now, but it's called like get game state or get current state or something. And it looks through the board and sees if there's stuff to be done, sees if there's moves to be made, blah, blah, blah. And they ask that, like, hey, are we still alive? And then it says yes or no. But I would rather get something more efficient. I think there's a way we can avoid that. And I think there's a way we can just more elegantly do it. Basically, I think we can just do this at the right time. So like in the sequence of things we do in a turn, we get the move, we shift the stuff, we put a new random one in. I think if we check this at the right moment in that sequence, we won't have like false positives, you know what I mean? Like we won't say, yes, we're dead, when in fact we're alive. So I don't know. I don't want to write a whole new thing. Maybe I could like use some of this other stuff, like this function. If it did something, it could spit out like, yes, I did something, or I don't know what. But that's my current state. And the game works. You can play 2048 all the way to the end, except you would die in some very rare situations where you shouldn't. And that's got to be fixed. So we'll look at that. And the cool thing about this code is that we can keep it, and then next semester when we learn how to do the graphical stuff, we can take all of this, just put a new skin on it, and display it in a new way. And probably, if I put this away and then open it up in a month or something, I'll realize a better way. I'll instantly go, oh, that sucks. Why did I type that? And then I'll do something to fix it. So currently I've got this folder with like 5 iterations of getting this better and better. And I think I'll add one more once we figure out the losing correctly. And then we'll call it a day on that. But it was nice to do this over the last 2 days, coming up with an idea, filling out the general sequence of what things would happen, and then running into 2 or 3 problems along the way, otherwise just rolling along.